Hi guys, we're solving the statistics paper today. This is 9709 paper 5-2, February March 2023. Paper 5 S1. Okay, so let's begin. I don't have access to the threshold yet because the paper isn't out officially. I'll leave a link in the description as soon as it comes out. So all non-exact answers should be given to 3 significant figures or 1 decimal place for angles and degrees. Okay, let's begin. So for the first one, we have a cumulative frequency graph. So we need to mention the CF first. So let's find out the cumulative frequency for the first class. It's going to be 4. This is going to be 4 plus 8, 12, followed by 12 plus 14, 26, 26 plus 25, 51, 51 plus 7 is 58, and 58 plus 2 is 60. Okay. Next. Let's draw the diagram. We need to give proper scaling. So you remember, you always have cumulative frequency on the y-axis, okay? So CF on the y-axis. Why don't I just draw a line? Wait. Here you go. There you go. Okay. So on the y-axis we have cumulative frequency. And on the x-axis we actually have x, the total number of hours of sunshine. Okay. So that's going to be hours of sunshine on the x-axis. X. So let's begin. So we need 60 on the y-axis, and CF always starts from 0. Okay, so this should probably be 10, this should be 20, this should be 30. You have 40 over here, 50 here, 60 over here, and 70 here. Okay, and on the x-axis we need to start from 30, right? 30 to 240 it seems. So let's start from 30. So we can opt for 30 on our scale. I guess that should work. Let's see. 60, 90, 120, 150, 180. Yeah, it perfectly matches. 210 and followed by 240 over here. Okay, so we're good. Let's draw the graph. So at 30 it's gonna start at 0. This is a given. It's gonna start over here, and then we have 4 at 60. At 60 we have 4, so that's 1 2 3 4 4 over here. And then we have remember that the CF corresponds to the upper bound actually. So we have 12 at 90. 12 at 90, we have 12 over here. Perfect. Then we have 26 at 110. At 110. So where is 110 actually? That point is going to be a bit hard to plot. Let's do that later. 140 is also hard to plot. 180, 50 at 180. 58 at 180, sorry, 58 at 180. 180 we have 58, and at 240 we actually have 60 sharp. Okay, so the middle 2 points, The problem with this graph is like we have odd numbers here, right? So I'm considering going for a different scale, honestly, like 40. I think it would be better. Okay, it's fine though. So 110, it's like 2/3, right? 2/3 of 30 is 110. So basically, 3.33 boxes, 1, 2, 3, 6.67 boxes. 140 should be somewhere over here. So 110 should be somewhere over here. 6.67 boxes away. That's 110 for you. So you can just plot it there. Honestly, it's fine. So we have 26 at 110. So I'm going for 26. 26 is over here. This is our point. And then we have 51 at 140. 140 is also like 6.67 boxes away from 120. So 6 over here. 6.67 is somewhere over here. And we're going to get 51. So 51. We get the point over here. Okay. So that's that. So if you plot the graph, it's going to be something like this. Let me use different ink, honestly. Okay. There you go. So this is our graph. It's going to be something like this. It's not recommended to use odd numbers. I mean, numbers that go with 3 on the x-axis, but it just matched so perfectly, right? Which is why I chose this. You could opt for a different scale, honestly, it'd be fine. Use a graph to estimate the 70th percentile. So what's the 70th percentile? 70 by 100 into 60. That gives you a value of 42. 70 by 100 into 60 gives you a value of 42. So we have to match this graph at 42 basically. So 42 is over here. You need evidence of this dotted line essentially. So it's 2 boxes from 120. So how much does each box represent? 30 by 10 is 3. Each box represents 3 hours of sunshine. So we are actually at 126. Okay. So 126 is the perfect answer, which I got perfectly. This is the mark scheme answer. The range was 123 hours to 129 hours. Okay. But I got the perfect answer. So my graph is alright. Calculate an estimate for the mean number of hours of sunshine during in Kin2 during June over the last 60 years. Let's estimate the mean. For the mean, we actually need the midpoint. Okay. So where are the midpoints? 30 plus 60 divided by 2. Since this is a continuous variable, we can just divide by 2. 45, 60 plus 90 by 2 is 75. And if you keep on going, the next one is 100, followed by 125, followed by 160, and 240 plus 180 by 2 is actually 210. So we are going to use these values and the values of frequency to calculate our value for mean. Okay, so let's find out the estimate of the mean. You got to show your working. So the first one is 4 times 45. 4 times 45 plus we have 8 probably. 8 times 75, 14 times 100. 8 times 75 plus 14 times 100 plus 25, right? 25 times 125, 7 times 160, 2 times 210. 25 times 125 plus 7 times 160 plus 2 times 210. Now this divided by the net frequency, which is 60. So we are getting an answer of, let's see, 4 times 45 plus 8 times 75 plus 14 times 100. Okay, so this is the answer that I'm getting, 1369 by 12. Which is correct to 114. Right to 3 significant figures, 114 is our answer. Okay, since it's an irrational number, you could also opt to write 1369 by 12. How much is that? 114 whole. 1 by 12 works as well, but I'm just going to opt for this answer. Okay. Moving on to question number 2. Alicia has 4 coins. One of these coins is biased so that the probability of obtaining a head is 0.6. The other 3 coins are fair. Okay. So we have 4 coins. 3 are fair. So the probability of obtaining a head is half. And in the biased one, it's 0.6 actually. So Alicia throws the 4 coins at the same time. The random variable x denotes the number of heads obtained. Show that the probability of obtaining exactly 1 head is 0.225. Okay. So probability of obtaining 1 head. So basically, you have the biased coin and you have the the fair coins. So what if I get head on the biased coin? What will it be like? So head on the biased coin multiplied by um, tails on the fair coins, essentially. Okay. So this is one way. They're thrown at the same time, right? So there isn't going to be like the order doesn't matter. And what if I got a tail on the biased coin? Okay, so that would be zero point 0.4 for tail on the biased coin. Then heads on the one of the fair coins, and then heads on one of the fair coins, and tails on the other two. Tails on the other two fair coins. However, this can occur in many combinations. Okay, what do I mean by that? Check this. So you have the bias coin, fair coin 1, fair coin 2, fair coin 3. Can't it be like this? Tail, head, tail, 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 head, tail, or tail, 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 head. So in total, there are 3 possibilities of this occurring, which is why we have to multiply 3 with this thing. So we end up with 3 times 0.4 times a half cube. Okay. So this is going to be 0.6 times uh, 0.5 cube plus 3 times 0.4 times 0.5 cube. That's how it works. So let's do that. 0.6 times 0.5 cube plus 3 times 0.5 cube times 0.4. That gives you an answer of 9 by 40, which is 0.225 shown. Very good. Complete the following table. So this is 0.225. We can just find out one of them and then subtract the other one. Okay. So let's go for 3 because it's going to be easier. Px equals to 3. How is that going to work? We're getting 3 heads, alright? So 3 heads. How does that work? Basically, in the biased coin, you can get a tail. And in the 3 fair coins, you can get heads. How will that work? So tail on the bias coin is actually 0.4, right? So that's 0.4 times 0.5 cube. So 0.4 times 0.5 cube. What is the other variation? Fair, fair, fair. You can get a head here, tail here, head, head, head here, tail here, head here, head, 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 tail. Okay. So what is this essentially? 0.6 for head times, half tail for the first fair coin multiplied by head on the other two fair coins, and this into 3 because there are 3 possibilities. Okay. So plus 3 times 0.6 times 0.5 cube. So let's do this. 3 into 0.6 into 0.5 cube plus 0.4 into 0.5 cube. Okay. So we're getting a value of 11 by 40 or 0.275. 0.275. And to get the last one, you can just subtract from 1. So Px equals to 2 is equal to 1 minus 0.05 minus 0.225 minus 0.275 minus 0.075. So if I do that, 1 minus 0.05 minus 0.225 minus 0.275 minus 0.075, we are getting an answer of 0.375. Perfect. This absolutely matches with the mark scheme. Moving on to the next part. Given that expectation is this, find out the variance. We know that the formula for variance is actually summation of x square into the probability minus the summation of expectation whole square. So let's begin, shall we? So it's x square probability, 0 square. First one is 0 square times 0.05 plus 1 square times 0.225 plus 2 square times 0.375 plus 3 square times 0.275 plus 4 square times 0.075. You need to show this much at least. Okay, this is one part minus ex whole square. So what do we get, guys? It's 0 plus 0.225 plus 4 times 0.375, which is 1.5, plus 9 times 0.275, which is 2.475, plus 16 times 0.075, which is 1.2, minus the expectation whole square, which is, where was it? 2.1 square. So what are we getting? 0.225 plus 1.5 plus 2.475 plus 1.2, 5.4 minus 2.1 square. I'm getting a value of 0.99 exactly. 0.99 is my answer. That's great. It matches with the mark scheme. Question 3. 80% of the residents of Kinwawa are in favor of a leisure center being built in the town. 20 residents of Kinwawa are chosen at random and asked in turn whether they are in favor of the leisure center. Okay. So guys, this is a binomial distribution. X is binomially distributed, right? So there are 20 residents in total, and the probability that they choose that they're in favor of it being built is 80% or 0.80. So essentially, more than 17. What does that mean? Px is greater than 17 people. So that means Px is equal to 18, 19, and 20. Okay, so what is that exactly? 20 C18 0.80 to the power 18 times 0.20 square plus 20 C19 0.80 to the power 19 0.20 to the power 1 plus 20 C20 0.80 to the power 20 multiplied by 0.20 to the power 0. Okay, so this is the working. Here you go. Now, oh my god, in the mark scheme they actually had the alternate method. You could subtract 1 minus 0, 1, 2, 3 to 17. Crazy. Anyway, let's write these values. 20C18 times 0.8 to the power 18 times 0.2 square gives you a value of 0.1369, right? 13691. Then 20C19 times 0.8 to the power 19 times 0.2 gives you an answer of 0.057646 or 765. It's fine if you write this, and this gives you an answer of 0.01153. So if you add all these up, you get an answer of 0.206 rounded off to 3SF. Okay, perfect. That is our answer. What is the next part? Find the probability that the fifth person asked is the first person who is not in favor. Okay, so now we are moving on to a geometric distribution. So X is geometrical distributed, and the probability of success over here is basically being not in favor. So being not in favor is 20% or 0.20. So the fifth person asked is the first one. So what does that mean? Px is equal to, let's actually use another letter. Let's use y. So Py is equal to 5. So what does that mean? We are going to get failure 4 times. Q to the power 4 followed by success on the fifth try. So that's 0.80 failure to the power 4 times 0.20, which gives you an answer of 0.0819. 0819, okay? Find the probability that the seventh person is the second person who is not in favor of the leisure center. Okay. So what does this mean essentially? Find the probability that the seventh person asked is the second person who is not in favor of the leisure center. So essentially, out of the 7 people you ask, individual 1, 2, 3, 4, 5, 6, 7, the seventh person is not in favor, so his or her probability will be 0.2, okay, 0. And over here, one of these 6 guys, we don't know whom exactly, but one of these 6 guys will have a probability of 0.20, while the others will have a probability of 0.80, 0.80, 0.80, 0.80, 0.80. So essentially this 0.20 is fixed, okay? But this 0.20 over here, it can actually interchange between all these 6 members. So what does that mean? How many options do we have? 6 options, 6C1 essentially. So this is how it goes. Check this. Probability equals to, it's going to be for the seventh person 0.20 is fixed, okay, and then this 0.20 is valid for any one of these 6 individuals, okay. And what about the other 5 guys? They have a probability of 0.80 each, so it's going to be 0.8 to the power 5. So essentially what happens is, check this, like let me break it down for you guys. This is another option, like these two can interchange. So what will this be exactly? Whoa, bro, check this. So what would this be? 0.2 times, we have this 5 times in a row, 0.8 to the power 5 times 0.20. And then what about this one? The first one would be 0.8 times 0.2, then 0.8 2 times in a row, then 0.2, which is basically 0.2 times 0.8 to the power 5 times 0.2, or 0.2 square times 0.8 to the power 5. Do you guys see that there are 6 ways of this occurring? Like this 0.2 being on the first position, second, third, fourth, fifth, or sixth. That's why I multiplied this 6C1 over here. So we actually end up with 0.20 whole square times 0.80 to the power 5 times 6C1. This is the first time I'm seeing this sum. I haven't seen this before actually. Times 0.2 square. This gives you a value of 0.0786. 0.0786. Interesting. Moving on to the next part. Question number 4. How many do we have in this variant? We have a total of 7 questions. So 4, 5, 6, 7. We're going to be done soon. The probability that it will rain on any given day is x. if it is raining, the probability that Aran wears a hat is 0.8, and if it is not raining, the probability that he wears a hat is 0.3. Whether it is raining or not, if Aran wears a hat, the probability that he wears a scarf is 0.3. If he does not wear a hat, the probability that he wears a scarf is 0.1. The probability that on a randomly chosen day it is not raining and Aran is not wearing a hat or scarf is 0.36. Okay, a lot of info. Let's break this down. So firstly, we have the day. The day begins with either raining or not raining. Okay, so the probability that it rains is x, and the probability that it does not rain is 1 minus x. Now what? If it rains, the probability that Aran actually wears a hat is 0.8. So the probability that he does not wear a hat is 0.2. Now, if it doesn't rain, the probability that he wears a hat is how much exactly? X 0.8 if it is raining, and if it is not raining, it's 0.3. So this is 0.3 and this is going to be 0.7. Perfect. Now what next? Now if he, so whether it is raining or not, so it applies to both scenarios. The probability that he wears a scarf is 0.4. Okay, whether it is raining or not, the probability that he wears a scarf is 0.4. This is valid for all cases. And if he does not wear a hat, the probability that he wears a scarf is 0.1. So if Aaron wears a hat, for both cases, if it rains or not, the probability that, let me draw this over here. So given that he wears a hat, the probability that he wears a scarf is 0.4. This is valid for both cases. So scarf when he wears a hat, yeah, it is actually 0.4. This is going to be 0.6, 0.4, 0.6. And if he does not wear a hat, the probability that he wears a scarf is 0.1 for both cases. Scarf, no scarf, 0.1, 0.9. Scarf, no scarf, 0.1, 0.9. See if you guys get it. I tabulated all the information in this tree diagram. Now the probability that on a randomly chosen day it is not raining and Aaron is not wearing a hat or scarf is 0.36. So let's do this, guys. So it is given that the probability on a randomly chosen day it is not raining. So I'm going to go for this the root that's down below, and Aaron is not wearing a hat or scarf is 0.36. Let's do this. So it's not raining. Probability that it's not raining and no scarf, no hat. Let's do this. So it's 1 minus x times no hat 0.7 times no scarf, which is 0.9. This is actually equal to 0.36, right? That is given in the info. So let's solve this. So 1 minus x is equal to 0.36 divided by 0.7 divided by 0.9, which is 4 by 7. So x equals to 1 minus 4 by 7, which is 3 by 7. Okay, that is it. Or you could round it off to 3SF, x equals to 0.571. There you go. Sorry, 3 by 7, yeah? 0.42, 0.429, 0.429. Perfect. I like this question. Marco. Is that a One Piece reference? Anyway, Marco has 4 boxes labeled K, L, M, and N. Okay. Now what? He places them in a straight line in the order K, L, M, N with K on the left. Marco also has 4 colored marbles. One is red, one is green, one is white, and one is yellow. He places a single marble in each box at random. Events A and B are defined as follows. A. The white marble is in either box L or box M, and B. The red marble is to the left of both the green marble and the yellow marble. Okay, determine whether or not they are independent. Interesting. So let's do this, guys. So we have a red, green, white, and yellow. Okay. So we have 4 boxes. We have K, L, M, and N over here. So, and we also have 4 marbles. We basically have a red one. We have a red marble. We have a yellow marble. We have a green marble. And we actually have a white marble, which I can't really draw over here. But wait, let me do this. We have this white marble over here. Okay, this is our white marble. Damn it, white. Okay, so let's find out event A. What is the probability of event A? Let's try doing this. So event A, white marble is in either box L or M. So 1 marble is placed in each box at random. So what are the chances that the white marble is going to be in box L or M? It's going to be 2 out of 4. 2 out of 4 chances, right? Which is half. That's great. Now let's go to the next one. Okay, so PB is a bit more complicated. How does PB work? So for PB, we actually need the red marble to be on the left of both the green and yellow marble. All right. So this can be done in 2 ways. You can either use the probability method or the permutation combination method. I'll show you both. So let's go for the permutation combination method first. So essentially, think of it in this way. What if the red marble is inside box L? Then the green and yellow one, okay, they need to be in these two. And any combination works, right? And what about the white marble? It's just going to be on this side. The white marble is going to be here. The white marble is going to be inside this box on the left hand side. Okay. So for the permutation combination method, by the way, what are the how many ways do we have in total? Total number of ways. We have 4 marbles and 4 positions, so that's 4 factorial or 24 ways. Okay. Now I'm talking about the first one. Red marble in box L. So how do we go through this? The white one has to be on the left hand side, so that's 1C1. The red one has to be inside box L, so that's 1C1 as well. And the red and yellow one can interchange their positions, so that's 2 factorial. So how many ways do we have? We have 2 ways in total. And if you want to go through the probability method, how do we do this? We will place the white marble in box K. So that is 1 out of 4 boxes. We place the white over there. Now I have 3 marbles left and 3 boxes. So I have to place the red marble inside box L. So that's 1. Wait, let me show it this way. Red marble in box L plus the other one. So this is going to be white marble in box K, red marble in box L, and the other 2 marbles, green and yellow, in the last 2. Okay, their positions don't really matter. Okay, because you can just multiply it off. Essentially, that's how it works. Essentially, it's 1 by 2 into 1 by 1 into 2, or just 2 by 2. Now, what about the second root? Now, the green and yellow have to be on the right hand side of the red one. So why don't we place the red one over here? Red marble in box K. So red marble in box K. So how does this work? The green, then the yellow, and the white one, they can just interchange their positions, right? Because the red one just has to be on the left of the green and yellow one. So they can take any position, honestly. The green and yellow ones can actually take any position, anything works. So they're interchangeable. So if we have 3 positions and 3 objects that can be placed there, it's going to be 3 factorial. So for the red one, okay, for the red marble, it's going to be 1c1, and for the other 3, it's going to be 3 factorial. So how many ways do we have? 6 ways. So in total, we have 8 ways. So what's the probability? It's 2 plus 6, 8, 8 by 24, or 1 by 3. 1 by 3 is our probability. Understood? And if you want to go through the probability method, what is it exactly? So we are going to place the red marble. We're going to place the red marble in box K. So that's 1 by 4. And then we're going to place the other 3 in the other 3 boxes in any order, honestly. So that's just 1 by 4. Okay, so if you do the math, 1 by 4 into 1 by 3, that's 1 by 12 plus 1 by 4. Let's do the math. We get an answer of 1 by 3. So yeah, both ways match. That's how you do it, guys. Okay. So we had to determine whether or not these events are independent. So for independence, we need to find out PA intersection B. We need to figure out whether there's any common scenario in both of them. So the common scenario is basically the red marble is on the left of the green and yellow one, and white is in either box L or M. So basically, the first scenario is excluded in the first place, because in the first scenario, red marble being in box L, the green and yellow ones have to be over here, right? The white one has to be in box K. That's fixed. That is why there is no intersection in this one. Okay, so the white marble cannot be placed in either box L or M in this first scenario. Okay, so we have to move on to the second scenario. Let's move on to the second scenario, where I'm placing the red marble in box K. The red one is over here fixed. Now the white one has 2 options. It can either be placed here or here. Okay, and the green and yellow one, honestly, they can just interchange their positions. So this is one scenario, and the other one is white being placed here and the green and yellow just interchanging their positions. Okay, so I'm just gonna find out the math for one scenario and then multiply it by 2, because it's going to be the same. Okay, so what am I doing? Red in box K, and white, right? White in box L specifically. So let's do this. It's going to be 1c1, red in box K, then white in box L, right? Or we could just do both, right? We could just write 2c1. That would work as well. Okay, it's fine. Then 1c1, white in box L. And then you have 2 spots remaining, M and N. And you have 2 marbles. So that's 2 factorial. So how many ways is that? That's 2 ways in total. But now we have to multiply this by 2. 2 into 2. We have 4 ways, because the white marble could be placed in box M as well. So we have 4 ways in total if you consider all the options. 4 out of 24. So 4 out of 24 is 1 by 6. That's the intersection. And if you wanted to do it directly, you could just do this. Red in K and white in L or M. That would be 1c1 into, white has 2 options, 2c1 into 2 factorial. That's basically 4 ways directly. Okay, that works. 4 out of 24 ways. So now we need to check whether it's independent or not. So PA times PB, how much is that? That's a half times 1 by 3, which gives you a value of 1 by 6. So it actually matched, right? So we have to write that since PA into PB is equal to PA intersection B, the events are independent. Hopefully that's fine, guys. Let's move on to the next one. We have 2 left. 66. In a cycling event, the times taken to complete a course are modeled by a normal distribution. So x is normally distributed with a mean of 62.3 and a standard deviation of 8.4. So we have 8.4 squared. That's your variance. Find the probability that a randomly chosen cyclist has a time less than 74 minutes. So this is what the graph looks like. Suppose this is 62.4. So it looks like this. So we want a value that is less than 74. 74 is somewhere over here. We want to find out this region, yeah? So Px is less than 74. So that is equal to um, I'm going to standardize it. Z is less than 74 minus 62.3 divided by 8.4. What do we get? 74 minus 62.3 by 8.4, which gives you a value of Pz is less than 1.393. Always go for 3 decimal places for normal distribution. So this gives us a value of phi 1.393. So let's look for that. 1.393. Let's go to the table. 1.39, 1.39, which is this 3, which is 5. We need to add 5 to 7, so 0.9177 plus 0.0005, which gives me an answer of 0.9182. I'm adding this 5 to this 7 here, the fourth decimal place. 0.9182. 0.9182 is my answer. 0.9182. Then I'm going to round it off to 3SF. 0.918. That is my final answer. Okay. Next, find the probability that 4 randomly chosen cyclists all have times between 50 and 74. So we have to find out the probability for one cyclist first. So P, now X is in between 50 and 74. So greater than 50, but less than 74. Okay, so let's do this. So let's standardize this. This is P 50 minus 62.3 divided by 8.4. 74 minus 62.3 by 8.4 minus P minus 1.464 and 1.393 over here. So essentially we can break this down now. We can write this as P, sorry, I meant to write Z over here, my bad. After standardizing, it turns into Z. So P Z is less than the bigger one minus the smaller one, always 1.393, the one after minus the one before, minus Pz is less than minus 1.464. But now we need to convert this negative value to a positive value. How do we do that? Pz is less than 1.393 minus 1 minus Pz is less than 1.464, which ends up being Pz is less than 1.393 minus 1 plus Pz is less than 1.464. So this is basically phi of 1.393 plus phi of 1.464 minus 1. So 1.393, it is basically 0.9182, right? 0.9182. Now I'm looking for 1.464. Let's look for that 1.464. 1.464. I'm adding 6 to this, 0.9279 plus 0.0006. I get 0.9285, 0.9285, okay. 0.9285 minus 1 plus 0.9182 minus 1. That gives you a value of 0.8467. Okay, so this is the probability for a single cyclist. Now, find the probability that 4 randomly chosen cyclists all have times. So basically, this for all the cyclists, it will be 0.8467 to the power 4, because all of them having this same time. Like, think of getting hits 4 times in a row. That's half to the power 4, right? This gives you a value of, how much is it? 0.514 to 3 significant figures, basically. If you have problem thinking of this, just think of, we can set up another binomial distribution. like 4 cyclists, and probability is 0.8467. Now I want py is equal to 4. What would it be? Basically 4c4 times 0.8467 to the power 4, right? That's how it works. Okay. Moving on, in a different cycling event, the times can also be modeled by a normal distribution. 23% of the cyclists have times less than 36 minutes. So this is our new normal distribution. Let's call it y. Y is normally distributed. The mean is mu and the variance is sigma square essentially. So one set of information is that 23% cyclists have times less than 36 minutes. So p y is less than 36 is actually 0.23. That is one set basically. And what about the other one? P y is greater than 54 is actually equal to 0.10. So let's standardize this. P z is less than 36 minus mu by sigma is equal to 0.23, and here it's going to be 1 minus p z, sorry, 1 minus p y is less than 54 is equal to 0.10, or p y is less than 54 is equal to 0.90. And then after standardizing, p z is less than 54 minus mu by sigma is actually equal to 0.90. So are we good till here? Is this okay? Now we're gonna face a certain issue. Like think of this. Think of it this way. Suppose the mean. Suppose the mean is over here. The mean is somewhere over here, mu, and the graph looks like this. Now, basically, above 54 minutes. If this is 54, we have 10%, and below 36. Okay, below 36, 36 is somewhere over here. It's basically 23%. Now, after you convert it to the standard normal distribution, this is the standard normal distribution Z. The problem is that, 0.90, we can really read it off from the graph. But as you can see, the issue with this, the value on the left is the lowest probability that you have is 0.5. The lowest probability that you have in the standard normal distribution is 0.5, which corresponds to a value of 0. But since we are getting a value of 23% in the standard normal distribution, what does that mean? This value over here lies somewhere to the left of 0. This is actually 23%. This means that our value of z is in fact not a positive value but rather a negative value. So you know the drill. I just taught you here. To convert a negative value to a positive value, we apply this method. 1 minus pz is less than 1.464. Similarly, this value is actually negative, but it's hidden inside. This value over here is actually negative, but it's hidden inside. So we have to do it a favor and convert it to a positive value. Okay, so this is my next step. 1 minus p z is less than minus 36 minus mu by sigma is equal to 0.23. This is what I just did. And what's the next goal? After moving it to this side, we actually end up with pz is less than minus 36 minus mu by sigma is equal to 1 minus 0.23, which is 0.77. Fine. So now, if you find out the value, this is the inverse one. This is the inverse of the standard distribution. We are looking for the closest value, 2.77. Now this value is greater than 0.5. We can look at the table for the closest value to 0.77. What is that? This one. Okay. You might think that this is closer, but you can't get a value which is higher. So it's 0.7673. And if you find out the difference between 0.77 and 0.7673, 0.77 minus 0.7673, we're getting a value of 27. So I'm looking for the value 27 on the right hand side, and I got it. Okay, so this value over here. So what will the actual value be after we confirm the inverse? It's 0.739. That's the value. Okay, so this is going to be minus 36 minus mu by sigma is equal to 0.739. And on the right hand side, 0.90, what's the closest value to 0.90? It's actually this value over here, and the difference is 3. Okay, so we don't have 3 over here, but we do have 2 and 4, which are both equally close to 3. So I'll teach you which one you have to take. So let's do this accordingly. So it's going to be 1.2. Okay, 1.28. Now you're at a standstill. You're not sure which one to take. So the rule is, if you have close equal proximity, like 2 and 4 are of equal proximity to 3, you always have to take the higher one. That's the rule over here. So it's going to be 1.282. 1.282, because 4 is higher than 3, and 4 and 2 both are closer, but 4 is higher than 3. Because if you took 2, you wouldn't actually get to that value, right? You'd fall short. That's why you need to take the higher one. So it's 1.282. 1.282. Okay, we're almost there. Now let's just finish solving this. Here we get 36 minus mu by sigma is equal to minus 0.739, or 36 minus mu is equal to minus 0.739 sigma. And over here we have 54 minus mu is equal to 1.282 sigma. So let's solve these, equation 1 and 2. I'm going to multiply equation 2 with minus sign, so we get minus 54 plus mu is equal to minus 1.282 sigma. So we get rid of these two. 36 minus 54 is minus 18 is equal to minus 0.739 minus 1.282. That gives you a value of minus 2.021 sigma. So 18 by answer gives you an answer of sigma is equal to 8.9123 SF. And what about mu? Basically, you can go for this. 54 minus mu is equal to 1.282 times 8.91. 1.282. Then 54 minus answer. Mu actually gives you a value of 42.623 SF, and these are our answers: 8.91 and 42.6. There you go. See if this makes sense, guys. Hopefully you guys get it. So this is a trick you have to apply. Like, if the value is lower than 0.5, always apply this method over here. Okay, and we also got the other trick over here. Like, we were unsure about taking 1.281 or 1.282. If there's close equal proximity, go for the higher one. Okay, really important sum. Let's move on to the last sum for the paper. It's permutation combination. We have this word delivered. So the first thing you have to do after you get a word like this is arrange the letters like this. So we have DD triple E, DD triple E, then LIVR, LIVR, liver, LIVR. So in total we have 9 letters, in which find the number of arrangements in which the 3 E's are together and the 2 D's are not next to each other. Okay, let's do this. So the 3 E's have to be next to each other. So we get E, E, E. They are together, and we have 4 other letters over here. LIVR. So LIVR, LIVR. For example, now how many arrangements are there for these? Basically, in total, if you think about it, how many units are there? You have these are single units, and the 3 e's are 1 unit, considered as 1 unit in total. So you have a total of 5 units over here, which can be interchanged. So that's 5 factorial for all of these 5. And then the 3 e's can interchange within each other, but you know, the 3 e's can interchange with each other, but they are basically the same, right? So you have to divide by 3 factorial as well. This is totally optional. I just like showing this. You won't see this in the mark scheme much. And now we have to deal with the d's, the 2 d's. They cannot be next to each other. So they have these specific positions. 1, 2, 3, 4, 5, 6. They have 6 positions. And in 6 of those positions, we're going to land 2 of those d's. So there are 2 ways you can do this. Since the d's are identical, you can just opt for 6c2. Or you could do this as well. You could write 5 factorial times 3 factorial by 3 factorial into 6p2 by 2 factorial. It's the same thing essentially. Okay. So let's try doing this. This is the same method actually, this one and this. So 5 factorial times 6c2, 5 factorial times 6c2, 1800. This as well. This is what they showed in the mark scheme actually, the one on the right. 5 factorial into 6p2 divided by 2. 1800. They basically showed this 5 factorial into 6 into 5 by 2, which is 1800. So this is the arrow method. Okay, you can do it this way. There is another method where you can actually consider the d's to be together, and then you can subtract it from the total number of ways. Okay, I'll show you that method as well. This is method number 2. So what are the total number of ways with the e's together? E, right? There are 3 e's, and then you have 1, 2, 3, 4, 5, 6 letters. 1, 2, 3, 4, 5, 6. So these are the total number of ways. Okay, total number of ways, that is equal to basically 1, 2, 3, 4, 5, 6, 7 factorial, 7 units divided by there are 2 d's here that are common, so divide by 2 factorial times 3 factorial by 3 factorial. This is the total number of ways. Okay, and what about the other one? Here I'm basically going to keep the d's together. Okay, so I'm going to keep the e's together. I'm also going to keep the d's together, and then we have LIVR. So in total we have 1, 2, 3, 4, 5, 6 units. So that's 6 factorial times 2 factorial by 2 factorial times 3 factorial by 3 factorial. So that's just 6 factorial. So if you subtract this from the total number of ways, what do you get? 7 factorial by 2 factorial minus 6 factorial. How much is that? 7 factorial by 2 factorial minus 6 factorial. We're getting an answer of 1800 as well. So this is an alternate approach that you can use. Okay, so this is the total number of ways with the e's together, and this is the number of ways with the e's together and the d's together, because we have to keep the e's together because that's a prerequisite, but we can't keep the d's together. So that is why I found keeping the number of ways where the d's are together, then I subtracted it from the total number of ways with the e's together. Okay, find the probability that a randomly chosen arrangement of the 9 letters has exactly 4 letters between the 2 d's. Okay, so let's do this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes over here. So we can keep 4 letters in between the d's. So let's do this. 1 d over here, 1, 2, 3, 4 d over here. Then let's just copy this. Let's copy and paste. Okay. So let's do this. D over here 1, 2, 3, 4 D, D over here 1, 2, 3, 4 D, D over here 1, 2, 3, 4 D. These are the number of ways. There are 4 ways in which we can do this. Now let's do this. So how many letters do we have left? We have 7 letters left. LIVR triple E, and they can be in any arrangement, right? So I'm going to do it for 1. What's it going to be? The D's are in place, so I'm going to do nothing with them. It's basically 2 factorial by 2 factorial. And then we have 7 letters, so 7 factorial divided by 3 factorial because 3 of the E's are common. 7 factorial by 3 factorial. That gives you a value of 840 essentially. And this can happen in 4 different ways. So I'm going to multiply 4. Then I'm going to get the total number of ways in which there are exactly 4 letters between the two D's. I'm done with that. Now, since this is a probability question, I actually need to find out the total number of ways where the E's are not together. Okay, this isn't the same as this. It's just the total number of ways. So it's going to be 9 factorial, total number of ways. It's going to be 9 factorial divided by 2 factorial into 3 factorial. How much is that? 9 factorial by 2 factorial by 3 factorial. That's 30240. So let's do the probability. What is the probability exactly? The probability is going to be 3360 by 30240. That gives you an answer of 1 by 9 exactly. Okay, so we get an answer of 1 by 9. Now moving on to the final sum of the day. Let's do this. 5 letters are selected from the 9 letters in the word delivered. So 5 letters are selected. Now find the number of different selections if the 5 letters include at least one D and at least one E. So we are choosing 5. 1, 2, 3, 4, 5. So let's do this step by step, okay? Don't rush. Oh, wait. Yeah, let's do this. So we have access to LIVR, we have access to triple E and to D's. So let's go step by step, okay? D and D, we need at least one of each. So it can be 1, 1. It can be 2, 1. Okay, I'm done with these. Then it can be 1, 2 or 1, 3. Okay. Okay, why don't I do it like this? 1D, 1E, 1D, 2E's, 1D, 3E's. There you go. Now, why don't I increase the number of D's? 2D's, 1E, or 2D's, 2E's, okay, or 2D's and 3E's. Maxed out, we can't have any more because the total number can be 5, okay? So it's either 1D, 1E, 1D, 2E, 1D, 3E, or 2D, 1E, 2D, 2E, and the last one is 2D, 3E. Let's do this. So 1D, 1E, we have 4 letters left and 3 spots. So that's basically 4C3, 4 letters, 3 spots. And then 1D, 2E, 1D, 3E. This is 4C2, this is 4C1. Then 2D, 1E. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Wait, let me just copy that. I guess it's better. One sec. Here you go. Yeah, so as I was saying, 2D, 2E or 2D, 3E. So this is basically one way only. It's 4C0 or 1. Here we have the other two, that is 4C2. This is 4C1. So let's add all of them up. 4C3 is 4. 4C2 is 6. 4C1 is 4. 4C2 is 6. 4C1 is 4 again. And this is just one way because there are no spots left. So if you add all this up, 4, 6, 4, 6, 4, 1, 4 plus 6 plus 4 plus 6 plus 4 plus 1, you get a total of 25 ways, and that is our final answer. Okay, see if you guys get it. So overall, pretty good paper. It was average. The difficulty was average. These are all common questions. The permutation questions are pretty common. We've seen this before. This is pretty common. This question was a bit hard. Obviously, the one piece reference. the one with Marco. Um, this one was a bit tricky, all right? And getting this tree diagram was the tricky part, but the math was actually easy. And yeah, this part was atypical, these 2 marks. We haven't seen this before. This was the first time, okay? So that's that, guys. I hope you liked the video. So I'm gonna link the paper for Feb-March 2022, paper 5.2 up here, and the paper for May-June 2022, paper 5.2 down here. And I'm gonna link the playlist for S1 up here. And subscribe to the channel if you like the content. See you guys.